Hi, my name is Jonathan Gladius, and this is going to be my cybersecurity final project. Today we'll be doing a simple Caesar Cipher C++ encryption project. Let's get into it. So, our agenda today is we're going to have a quick history on encryption. We're going to discuss how the Caesar Cipher works. We're going to do a C++ implementation demo. We will discuss some weaknesses with the Caesar Cipher, and we will go into some educational conclusion and show some references. So, some quick history on the encryption. The first earliest recorded form of symmetric encryption was invented by Julius Caesar in the 1st century BCE to protect confidential military messages. He used a simple letter shifting technique to make military orders unreadable if they were intercepted by the enemy. Historically, Caesar used a shift of 3 letters. So, to explain that further, say for example, I wanted to encrypt ABC in that order using the Caesar cipher. I would shift each letter by 3 letters in order to make this work. So, for example, A, if I go 3 letters over, would be D. B, 3 letters over is E. And C, 3 letters over is F. So essentially, if I wanted to encrypt the letter ABC, then it would become DEF. And the same is used to decrypt it, that same key. So if I wanted to decrypt the DEF, I would shift back 3, and then that would become ABC. So this ultimately became the foundation for modern substitution ciphers and ultimately for today's complex encryption algorithms. So how the Caesar cipher works, we've already kind of given a quick intro about it. The encryption formula is a capital C equals open parentheses capital P plus a lowercase k close parentheses keyword mod 26. Now, the capital C stands for your cipher.txt file. We will get into that later. Your capital P is your plain.txt file. We'll also get into that later. And then your K, the lowercase k, is your shift key, which is essentially the key that we will be using for our encryption decryption today. So the encryption command that we will be using today is -E space -K space 3 dash or space -I space plain text space -O space cipher.txt. So essentially that's basically saying we are going to encrypt using a shift key of 3. We're going to insert our plain.txt file and we are going to output our cipher.txt file. Our decryption formula, capital P equals open parentheses capital C minus the lowercase k plus 26 close parentheses the keyword mod 26 process. So our decryption command is going to be -D space -K space 3 dash space -I space cipher.txt. Essentially, that would be decrypting using our key of 3, and we're inputting our cipher.txt file. So the example that we're going to be doing today in our plain.txt file is great learning. The key is going to be 3. And hopefully our result should sound something like this. It will be a capital J, capital U, capital H, capital D, capital W, space, capital O, capital H, capital D, capital U, capital Q, capital L, capital Q, capital J. So let's get into the demo. So I'm going to go ahead. I have my great learning. I'm going to go ahead and save this as my plain.txt file, and I will then add it to my project directory. So we're just gonna go ahead and close this. As you can see, those are our commands that we will be using today. Let us see where that got saved at. I should not have closed that. Very unfortunate. Copy. We're gonna put this in here. And there we go. And we're just gonna open and close our Visual Studio project. All right. This is my main.cpp file. Not gonna go too much into it, but it was a lot of hard work. I will say that. We are now going to go into our project properties so that way we can add our encryption command. You see, this is our earlier decryption command for my testing. So we will start with this. We're going to apply it. We're going to press OK. And now we are going to start without debugging. So it finished. Now we will take a look in our project directory. As you can see, there is a new cipher.txt file. And as you can see, this is the expected output that we got, which is beautiful. So now what we're going to do is we are going to reverse decipher it. So now we're going to take our decipher command. We're going to do the same thing. We're going to come into our project properties. We're going to change our command argument to our decryption command. We're going to apply it, press OK, and we are going to run without debugging. And as you can see beautifully, it decrypted our text from our cipher file, and we got great learning. Beautiful. So coming back to our presentation, the weaknesses and how to break the Caesar cipher. So the key space, there's only 26 possible shifts, 0 to 25. You can basically brute force attack it, essentially trying every key in seconds. If you do a frequency analysis, letters like E, T, A occur most often in English. By comparing those frequency patterns, the shift can be easily deduced. If even one word is known in your plain.txt attack, like, it's over. That file is going to be easily decrypted. The key is discovered. And modern computing can break the Caesar cipher in microseconds. It's that simple. In conclusion, encryption is a matter of transforming readable data into unreadable data. Decryption is reversing that process using the same or related key. The cipher demonstrates symmetric key principles. In programming this, I applied loops, I had character encoding, some modular arithmetic. There was some command line flexibility with the encryption and decryption command, and we obviously practiced clean error handling and parameter validation. I learned a lot in cybersecurity, just importance of the key size, the randomness, the algorithm complexity, how simple transformations inspire but can't replace real cryptography, and the connection to modern algorithms such as AES, RSA, and ECC. Thank you for tuning into my project today. Hope you have a great day.